Hello, everybody. It is 8:45 a.m. Central Time on the 27th of June, 2018. It is Wednesday, going into Thursday internationally. Hope you are doing well. We are here on the Earthquake 3D live stream to do an update, and last night did not do the 10 p.m. update. Went to bed early, got up early, had some stuff to do, and I hope you guys were able to get through the night. Oh, let's talk about seismic events that have struck in the last 24 hours. We'll just look at a full 24 hours since my update yesterday and get a good picture of what's happened. Let me turn on a display capture, and we'll jump over looking at 24 hours here. So we have a pretty significant amount of activity. With yesterday's update, we covered Japan. You can see that marked in pink. So the earthquakes marked in pink are the earthquakes we covered yesterday, and the earthquakes marked in white are everything that struck in the last 24 hours. So it's fairly obvious we went from Japan yesterday morning, across the day last night, and into this morning with a series of earthquakes all about the same size, 4.8, 4.8, 4.8, 4.8, spreading around the whole West Pacific, with the biggest of the bunch, a 5.4 and 4.8, now downgraded to 4.7. Striking right in the middle next to Mount Ibu and Mount Dukono, also next to our letter D. And then in the middle of our fours, here, a silent zone where Mount Krakatoa has erupted, and the deep 5.3 that set this all into motion several days ago. You'll see that marked in a darkish red here, raised high off the globe, right in the middle of this whole thing. So we got a push to begin with from down below. That has now spread out across the area. I think that's fairly obvious. And 4.8's the number of the day all throughout yesterday, and then mixed in between the 4.8 smaller earthquakes, so 4.5 and a 4.6 and a 4.0. We go up into Japan, and what other numbers do we have? Well, of course, we have 4.8 and 4.8. Those are the largest of the bunch, and mixed in between those, what do we have? 4.6's. So it's the entire West Pacific being displaced on a 4.8 basis in the course of 24 hours. That's what we're looking at here. Now, what could displace the whole West Pacific on a 4.8 basis, and then right in the middle of it, we have a 5.7 or a 5 point, what is this again? A 5 point, let's get the stats on that. 5.4, USGS 5.4. So we get the largest of the bunch in the middle next to the volcanoes, and then spreading out again. It's so obvious. As we go over towards Mayet Island, word has reached me, and this is coming from where there's that site where people made a false accusation. Well, down below, people have left testimonials, and somebody from Facebook came over, and apparently, now this is just from their report, the person in charge, or people in charge at Mayet Island, have contacted the U.S. somehow, the State Department or something, about my videos, and they're not happy about my videos, apparently. Apparently, my videos are the ones that matter, and everybody else's don't. So if you're a bigger channel than me, and you've been covering Mayet Island, you don't matter. The only person that matters is Dutchsinse and his views on the island, okay? So they're apparently upset about my videos talking about it, even though the other people with bigger channels are talking about it. And they're okay, even though they're saying it's going to be a blow, and saying it's going to blow up and all kinds of stuff. That's okay. But if I tell you about the earthquake swarm there, that's a real problem, and we got to take care of that one. So as we go across over to the west, or west-northwest from Mayet, we're not going to talk about it. We're going to go over here, and we have a 4.5 and a 4.0, which was upgraded to a 4.2. Those fours went over to the west, and we got a new set of fours breaking out where? Well, right at the border of Turkey in the Aegean Sea. 4.4 striking next to the Isle of Lesbos, 4.4. So where's that coming from? It came from the Middle East, and it's going to be going up to the west-northwest. We already had our 5, and if we needed any more proof that there was activity going on, how about a rare earthquake along the English Channel, 5-kilometer depth in the UK? Now, you know, guys, I actually got to stay right down here when I went to the UK for a month. Got to stay right down here just to the west, down at Devon. Real beautiful place. Really, really awesome. Right next to where they set sail from Plymouth. And you got the Pilgrim location there to the west. And, oh, yeah, real good stuff here. But we're south of London. We're actually set in a little bit from the coast. I mean, it's not right along the coast. It is north. But here it is. Now, I'm wondering, I just have to wonder, are they doing any kind of shale exploration or fracking or oil pumping anywhere around here. Now, we would have to go check it out, but you're right next to a airport of some kind. I would just wonder if there's something going on there, in case you don't know. Oh, you got to look at the name of this town right there. Yeah, time for me to move there. Okay, so we go over to the west, and what do we have? We have 2s going all the way across, going out to the Azores near 3. We also have a 3 up at Iceland, and a very rare 3.7 striking between Sweden and Finland. Between Sweden and Finland. Now, there's been a recent increase in earthquake activity up here across Sweden, Norway, and now reaching over towards Finland. It's worthy to note that the Europeans have built 5, or are building 5 new HARP-type arrays that are much bigger. And all 5 different antenna fields can be targeted, and it's operating on the FM bands. FM, like FM radio, but it's in the 200 FM band. So just above where your dials might go on a radio. Your radio might go up to 108 FM or somewhere like that. Okay, well, right around 200 FM, they've got these facilities, and I'll show you really quick. I've got a video on this over on my YouTube channel, but we can just search it, EISCAT3D Dutch Sense. There we go. Here's my video from April 20th of 2015, and let me just quickly fast forward through look at the description. Okay, this is from their information here, and I've got all the links down below if you want to check it out. Again, links are down below to the information if you want to go over to their website and check it out. But you can see the graphic. Here's the 5 arrays across Norway, and they target it up into a sphere where they create superheated regions of plasma air glow in the upper atmosphere and ionosphere, and they're able to target these. Where the beams cross, there is a scalar which forms, just like the scalar which forms inside of CERN where they cross the beams, only this is over a huge area up in the upper atmosphere and ionosphere. And this can be targeted all over the place. So this is just one description of it, and then here's a shot of their computer animation, this is from them, of what one of the arrays is intended to look like. Just so you get a picture. HARP has 180 antennas. Each one of these is going to have something like 50 to 100,000 antennas. That's right, HARP has 180? They're going to have 50 to 100,000 just at one array alone. Now, they've already brought one online, and the others are being built now. Now, you start seeing an earthquake increase around the Scandinavian countries. When they're starting to mess around with radio waves on this level, we have to understand that there's a power conversion that happens between radio wave and crust. Now, this gets into some very complex science, but I can sum it up as basically radio waves act like electricity in the atmosphere. And there's a discharge that happens when there's too much radioactivity in an area. When too much radioactivity is in a concentrated area, there begins to be actual electron cascade. Think of scuffing your feet across the carpet, and you can go shock yourself. You store up that charge in your body like a capacitor, or like a battery, but more like a capacitor. Well, the atmosphere will do the same thing, only it starts to glow. The air starts to glow. We know that as northern lights. When the sun does it to us, when the sun bombards us with charged particles and radio waves from the sun, if you will, those particles cause a air glow called the northern lights, and it's very powerful. It spreads out over many, many hundreds, if not thousands of miles. Well, this can be targeted down to a small spot in the upper atmosphere, and it causes the same phenomenon, but very concentrated and super hot. It'll be in a form of a ball, a sphere in the atmosphere that can be grown or shrunk. It can be invisible to the human eye at first, or they can actually pump it up to the point where it becomes visible air glow. Now, that's done with radio waves. Those radio waves convert into DC power directly in a process called efficiency scaling. The efficiency scaling can discharge into the crust, as found via experiments at HARP and others, that there's a magnetic resonance that will go all the way around the Earth, down to the opposite side of the planet, at a place at the antipode of the magnetic resonance to begin with, or the radio wave transmission. And they found, for instance, HARP has a magnetic conjugate point, the opposite point on the opposite side of the planet, down in New Zealand. Off the coast of eastern New Zealand by a few hundred miles, HARP has a magnetic conjugate point. So they placed a buoy A floating buoy with a VLF and HF radio receiver on it down off the coast of New Zealand to see how much of the transmission and power was coming through. And what they found was all of it was coming, a 90% efficiency, so only a 10% loss of power coming all the way around the planet. And it comes down, and the VLF, the HF and VLF, two different types of radio waves generated from plasma in the atmosphere, very low frequency and high frequency, that was coming down and going down to the buoy and beyond the buoy and going down into the crust. And then Mother Nature was reflecting it back up. And when it went past the buoy down into the crust and came back up through the crust, there was a power conversion that happened from VLF to HF. So from very low frequency to high frequency, and from high frequency to very low frequency. And there was a loss of power somehow, that there was a storage of power. They never determined, or at least it didn't say. Where did that extra power go? It went down into the crust. Now, will that cause an earthquake? Yes. How do we know? New recent studies have been released in the past few weeks about VLF earthquakes. VLF earthquake, oh boy, signature. Let's see if that comes up. And let's search tools, anytime, past month. There we go. Journal of Nature and Science, June 20th. Anomalous variations of VLF sub-ionospheric signals involved with earthquakes. Ionospheric signals and mesospherics tied with earthquakes, with the Gorkha, Nepal earthquake. So this is just one example where they detected ionospheric and VLF now. VLF being detected. Sub-ionospheric signals before the earthquake. So there's a magnetic resonance that happens, and a VLF to HF conversion that can cause earthquakes. So we start getting earthquakes up here. Why? Well, they're beaming out a huge amount of radio waves that go up and come back. And when they come back, they go back down into the ground. They don't just hit the antennas. They hit everywhere around. The antennas collect the amount that's transmitted, but there's a certain amount that's being discharged into the crust. That's not my take on it. That's the science behind it. I was called a conspiracy theorist for saying these things were possible back in 2011. Now all those studies prove it. So that's your little lecture on plasma physics and the earthquakes over in Europe. Now let's jump down to New Zealand for my Kiwi viewers. Hey guys, check it out. Look what happened today. You guys started to get smacked around a little bit by new activity coming in. From where? Coming from the north. And take a look at the North Island if you needed any more proof. So we got mid-range threes, bunch of twos starting to strike. Where? Across the North Island, bottlenecking down at the Cook Strait. And down to the south, we just have like two small sets of quakes here at the south tip, which a huge silent zone in between going across the Southern Alps, across Canterbury, up into the Cook Strait. So our largest activity so far on the North Island, and we're expecting the plate boundary to come under pressure here very soon. Very, very soon. You know, something else that I found today I would like to bring to your attention. I think, I don't know where I posted this. Let's go over to Facebook and see if I posted it over there. This has to do with earthquakes as well. We've got some other stuff on Facebook, of course, which I think I'll just skip over very quickly. Okay, we'll skip over that. Here we go. Check this out. Look at this. Forbes today. New study finds everything we told you about slow slips leading to large earthquakes is true. 3 to 4 years ago, mocked across social media for saying slow slip bursts and pockets can lead to large earthquakes. Now in 2018, they find out pockets or sudden slips do indeed lead to large earthquakes. Now what does that have to do with New Zealand? What does that have to do with what's going on around the rest of the plate? Well, we've been telling you guys slow slips lead to large earthquakes when they happen in pockets. Well, down here in New Zealand, there's a slow slip happening off the north part of the eastern part of the North Island. And that's moving right now. So it's moving as we're talking, and not just today, but over the last several weeks and months. The professionals have been talking about it down there. Slow slip happening down in New Zealand. Well, if a slow slip is happening in New Zealand, and it can lead to a large earthquake, according to professionals, not just every single slow slip, but when we get a big slow slip, a big pocket that starts moving, they are now releasing that it can cause large earthquakes. And that's a big deal because I was literally mocked and ridiculed for saying that. They said slow slips released pressure, that they didn't have any kind of stress or buildup that caused large earthquakes. Isn't that wild? So now they confirm it, and that's in today's news. As we get out across the Pacific, we'll go over to Central America, then we'll talk about Hawaii in a second. But take a look. Let me get a sip of my coffee here. Ooh, very good stuff. So yesterday, going into today, a series of 5s broke out across the Galapagos, where we did our update yesterday. They elevated or upgraded that earthquake to a 5.5. So it's a significant sized earthquake there. Then a new 5.2 struck after that in South Mexico, right next to Guatemala. New 4s, mid-range 4s, striking in Guatemala, spreading down into El Salvador as well. And over here to the east, looks like we're still maintaining a steady beat of a drum at 3.0 activity, mid-range 3. There is a slight increase in magnitudes here. It could go up to 4. I mean, you're flirting around with it already. You got 3.4s out here. I really think, though, over to the east, we're looking at another 5.0 earthquake. We're also looking over to the west, here near Jamaica, for another earthquake in the 4 range. So it's going to be pretty significant, I think, throughout this week for the Caribbean. We have to keep watch. With all the other 5s spreading out around the plates, that's not my take on it. Look at the last few days worth of 5s. Man, we have really increased in the magnitudes around the plate. We went from 4s, get the 4s out of there, boom. Oh, wait, here, there we go. You can see it. So, I mean, this is yesterday and today, pretty much. And we can see our spread of 5s. Now, why are 5s suddenly spreading out? There's been a series of deep earthquakes that happened that pushed the whole plate. Professionals denied this as well. They said deep earthquakes did not cause shallower, larger earthquakes. Isn't that wild? I've got that on quote from a medal recipient winner, geophysics medal winner, though the top guy in the industry, said deep earthquakes don't cause shallower, larger earthquakes. How about that? Oh, here we are, and we see it happen on a daily basis. So whatever the medal winner says, or any other person says, well, we see it, we observe it. Whatever they say doesn't matter. We're observing it happen. They're wrong. And here's a translation of earthquakes across the plate that goes from deep over here and a set of 5s spreading out to a 5.7, going down to a 5.5. Guess what's the next stop on the list? You can see which way the earthquakes are heading. It's a progression. It's a line. The older earthquakes are marked in dark red. The younger earthquakes are marked in pink. You can see which way it's moving. It's moving from where the red is to the pink. And it's going to be filled in with a new white-colored earthquake over here to the east as the 5s spread over to the east. Now, one final thing before we get into Hawaii. New 5.2 has struck on the South Mid-Atlantic Ridge. Where did that come from? All we need to do on this is just go back a few days as well. Look what struck up to the north. Look what struck up to the west. Now, you might not see it, or you might not know what I'm talking about. North and west of here, we have a series of 5s that broke out many days ago, 4 or 5 days ago, and it was a 5.7. Now, I've told you in the past, force tries to flow down, around, and underneath South America. And if you follow this on a progression line, we go down, around, and underneath, well, you're going to come up on the South Mid-Atlantic Ridge going down to our X's. If you go back to last week's forecast, we talked about this specifically. South Sandwich Islands getting hit, and the South Mid-Atlantic Ridge getting the leftovers, or in some cases, a full push, depending on how big of motion we start over here on the western side of South America. Think of this like a giant flowing force of water, and this is a giant rock in the river. It's going to hit the rock and break around it. Eventually, it'll wear it down over time, and that's why we have bends like this coming down and around the south tip of South America and going up and around the north tip of South America. That the reason that's bending around the plate like that is over a long period of time, Mother Nature has done this. The plate has bent and flowed around, almost like a flowing fluid. Now, I don't think anybody would be shocked to hear that, because we know that most rock and most solid substances, while they appear solid to us, are still fluids in motion over a long period of time. I know it sounds absurd, but you can see this taking place in old windows, for instance. Some old windows, hundreds of years old, have started to slightly, they get like an appearance of almost looking like you're looking through flowing water. And the reason is, over the time, the glass has actually flowed down and sagged with the gravity pulling on the glass over time, even though it's a solid. As we look out here to the Central Pacific, before we get into the United States, I've got to talk about something going on at the North Central Pacific. Today, new reports coming out about Cleveland volcano. So let's go to Cleveland. volcano, do the search. There it is. 14 hours ago, 1 hour ago, Alaska's Cleveland volcano could explode in days. Threat level raised by the USGS and Alaskan Volcano Observatory. And I'm not going to show you their news stories because they inevitably give you some kind of copyright stuff. So you just got to understand the activity that's going on up here in Alaska, right here at the center of all this. So right at the center of all these earthquakes, we have Cleveland volcano. And we talked about Cleveland volcano last week. So now here we are. Cleveland volcano now coming to life. And it's blew up, a few months ago or a couple months ago there was some activity. Now it's back to life. So Cleveland's going, resurging. And if you read the stories, they're talking about magma appearing suddenly on the inside of and surging up. Well, there's magma surging at the North Central Pacific, guys. So let's get out here into the Central Pacific and talk about what's going on around Kilauea. Well, Kilauea is still swarming, and we have a series of earthquakes that have spread out in a circle, around Kilauea over the last several days, going out 20 miles in each direction, or 40 kilometers. 25 miles, 40 kilometers, something like that, spreading out around Kilauea in all directions, in the same magnitudes, mid-range 3s at the perimeters all the way around it. So today, in the last 24 hours, you'll clearly see that we have a cluster of 3s developing off the coast by about 50 miles or so, and then we have a cluster of 2s, one of which is happening on the flanks of Mauna Loa again. The other 2s are going up towards Hilo, in between Mauna Loa and Mauna Kea to the east of there. But the main brunt of this is still happening at Kilauea itself. But I just mentioned Cleveland volcano just to your north. Well, I shouldn't say just to your north. It's pretty far to your north. They are connected. Across the Central Pacific, they are connected. When Hawaii collapsed last time, guess which volcano went? Cleveland. That's right, within a day. Or was it 2 days? Okay, well, let's just say within 48 hours of Hawaii going, Cleveland blew. This past time, like just a few months ago when this whole thing started, a month and a half ago. Well, now here we are again. Cleveland's resurging. So I have to raise this and go take you over to the Hawaiian Volcano Observatory, where they just did this. They took it from red down to orange about 2 days ago, which is highly abnormal. That's not wise. The thing is still erupting. They're taking it down. They say there's no threat of a blast. Guys, look. There's magma resurging. Oh, they've released new video. That's right, I forgot about this. They released this yesterday. We're going to show it to you now. Let me turn off the audio. So the aerial survey, and it was released yesterday. It looks like they got drone permit. Hey, there's Bob the Bush making his camera debut. There we go. There's where the trees were falling. Look at that. Okay, yeah, they got a shot of where the trees fell. No doubt about it, tree falling off. But really, what you're going to see here is amazing when you look out across the edge of the rim. It's collapsed. It's fallen in. Now, the road is still there and intact, and it looks like that side of the crater is somewhat still intact. Not much rubble down below, except for maybe regular erosion on the side. This is where we get interesting, going over the fissuring and cracks that are forming, where this could still, theoretically, subside in all the way out to where this fissuring is occurring right now, or even further. So take a look at where it's fissuring now, as of just a couple days ago, and where it's fissuring and all those cracks are. That's where we can see further collapses. Now look how far down that's going. It's going down 1,500 feet, 2,000 feet. The old crater floor is sinking and sliding away. And the crater floor goes up into the caldera we're looking at. Oh, they just cut, man. They just cut it again as we were trying, as they got to the HVO. Look, let me just pause it right where they cut it. We get right over here. We start getting to right by where the HVO is. I think. I'm pretty sure. There it is. There's the HVO right there. And the tree that fell was somewhere right down here. Bob the Bush's relative fell. It wasn't on any one of these lowers. It was a treetop from right in here. Okay, all right. Let's keep on going. So they cut it right at the last frame there. Now we're looking down inside the pit itself, and this is the former crater. you're looking at part of the crater floor going by on the screen here. So the crater floor here, and there's another section of the crater floor further higher up, but they're not even bothering to look at that. This is down at the bottom. The lava lake is down below here. You see where that steaming is happening down at the bottom of the crater? That is where we have down below there is the old tube that fed the lava lake. This is the old portion of the crater still high up. So that portion has still not fully collapsed. And where we have steaming, these are sections where we're most likely going to have new cleavage and breaking off of the sides. So I'm glad they're taking the detailed time to get this out. Are we going to pause? Hold on. It looks like it's stopped halfway through. All right. Looks like it's stopping halfway through. I don't know why that's happening here. But I think you get the picture. We could stop it right there. I mean, this is giving you the good picture. What I'm concerned about down here at the very bottom. This is the bottom of the new collapsed crater. There's millions of tons of debris on top of where there used to be magma. So let's jump over and show you out here in Hawaii what Hawaii used to look like at Kilauea. And then we'll again show you what it looks like now. Where are we? There we go. Off the west coast. Man, things get turned around on Google Earth really easy. Here's Kilauea, and this is what it used to look like. A oval-shaped greater caldera inside a crater somewhat circular-shaped, and inside the crater, the old lava lake. This thing drained out completely, allowing for this to collapse. It collapsed and spread out into the greater caldera, which we just got done looking at, with a huge open pit now much larger than what originally existed. Now, the magma is still down inside the volcano somewhere, and with a resurgence of pressure coming across the Pacific Plate right now, it stands to reason that this should fill back up at some point. Now, when it fills back up, it's going to hit this down at the bottom of the crater, which is blocked. And when I see steam coming up at the very bottom, down below here somewhere is going to be where that magma resurges. But it's going to hit a cork at the top that's several hundred to maybe even a few thousand feet thick of rubble. And it's going to build. It'll start to dome out, or if it gets covered even more, we won't even see the dome. Right? So if it keeps getting collapsed on top of, you won't see a rising dome, even though there is a rising dome of magma that would be down there as it resurges. But once that resurges, it'll blow. That's my call. I might be wrong, but once the magma resurges back up here into this pit, it's going to blow. I mean, what else do you think is going to happen? Do you think it's just going to ooze out and come in and make a new clear lava lake that's perfectly round like it used to be? I mean, what are our options when magma is reintroduced to a chamber or to a tube that's blocked at the top and it's an active volcanic magma chamber below that's getting new pressurization as new magma comes in? We'll know eventually here. We'll know very soon. I would say within the next couple of weeks, we will know. How will we know? Well, the fissure over at Fissure 8 will slow down big time. So the river that's feeding the ocean right now with new lava spreading out across the landscape, that will start to get way less. Once you start seeing that get way less, you'll know that the magma chamber in Kilauea is resurging or refilling. Okay? And it won't take that long. And we'll see a new eruption. We'll see a new blast as a new crater forms there once the pressure gets too great. That's my call on it. I don't think professionals will agree with me at all. They never do on anything I say, even if I agree with what they say. So if I repeat what they say, then they disagree with it. It's hilarious. As we look over to the United States. Oh, and earthquake-wise, one other thing. Earthquakes, we can expect certainly new 5s, mid-range 5s, as this thing continues to collapse and spread across as these new fissures happen, and it breaks and cleaves off and falls in. New earthquakes. And look how many you probably have lined up here. Think about how many more earthquakes you have yet to go. Let's see. Each one of these is a new 5, okay? If it continues to collapse. So every one of these little break-off points here will be a new 5. So you're looking at a lot more still to come. That's just right here. You got all the way around the crater where this can keep on going. That's why you're getting so many 5.0 earthquakes as it stands right now. Okay, now let's get into the United States. Last 24 hours. Take a look. Let's turn on our last 24 hours 0.0 and greater feed. That would be the most appropriate. We can see all the smaller earthquakes, the larger earthquakes, anything that struck in between. There we go. All right. Is that right? Here, let's hit refresh. Yep. All right. Okay, so we'll be able to see. Oh, wow, we did. We got some activity in the Midwest. Oh, right at the Texas border. 2 different 2.4s. Let's go put in the Texas coordinates. Oh, they have it listed in Oklahoma. Man, it's right on the border. Okay, we'll put these in. Come along with me. Let's go show you what's there. There's a reason the earthquakes are striking here. It's not just a random coincidence. So what should draw your eye would be these. I mean, these would attract anybody's attention if you look from above. And what you're seeing here are oil pumping operations. Now, we might call that fracking, but this is oil. This is a large oil patch spreading out across maybe several miles. And our earthquake is striking right next to it. Let's see if we have a nearby well that's even closer. Oh, yeah, we should do it right next to the earthquake, right here. This looks like fracking, though. This one here looks like fracking. The other ones right next to it look like oil. Wouldn't surprise me if they're doing both, gas and oil, and fracking and wastewater disposal. Probably all that at the same. Now look at our other operation up here to the north. So I've got some of them marked, but for every one I've got marked, there's even many more in here that are not marked. Either they do new expansion, like these, this is 2017 imagery. Look how brand new these tanks are. All brand new, protective pads, everything. Well, at least they're taking safety precautions and measures now. Better than just sticking it in the middle of a field like they used to. Okay, well, let's take a look and see what else is going on here. We're going to go just to the north. So 2.4 at this location I just looked up, and here's another 2.4. Several counties to the north. What's at this location? Let's zoom in and see. Well, we got a few houses, okay, right at the epicenter. And right next to the epicenter are imagery dates from 2016. So, I mean, they could have expanded since then, but we always look within 6 to 10 miles, like the USGS used to before they stopped looking. And here we are, yeah, oil and gas, no doubt about that, another fracking operation. Now, the real question is, do they have any over here? Oh, yeah, look. We got the shadow of a pump. Look, there's no protection around it at all. This is how they used to do it. Just plop it down in the middle of the field and it spills, screw it. Here's another one. And the tanks. Rusted out and old, but still working, probably. Okay. I mean, I think you get the picture of why an earthquake's striking it. Drill points. Drill points are weak points. We're going to start up here in the northwest, where we have no earthquakes reported out of Washington in the last day. We go over to the east, and we have a small swarm of ones breaking out on the northwest edge of the North American craton. Now, the craton, I talk about it all the time. I'm going to show you a graphic. I show this all the time. Northwest edge. Look up to the northwest. Look up here on the tip of Wyoming, where that black arrow comes in. And that's the edge of the craton. Now, you'll see it goes up into Montana and carries on up into Canada, just as a reference. The interior brownish-orange color versus purple. So keep that in your mind, and then we'll go back here and look, and you'll see that's where our earthquakes are residing here, right along the edge. Just a series of ones. They're small. They're microquakes. As we go into Oregon, let's go check this one out. Oh! Oh! Uh-oh. Looks like we've got another explosion. Well, let's go look it up. Maybe we've got a quarry. Maybe there's a quarry here this time. Maybe it's not rednecks with tannerite. Maybe it's something else. Let's go see. No. This one's on a river. I know what it is. It's the rednecks again. They're out there in a boat, and they're dropping M80s into the pond. You know, redneck fishing. I mean, why bother with a pole when you can just drop an M80 in there and get all the fish out that you need? It'll get the gators out, too. Lots of gators up here in the northwest. So let's go down across Oregon here, and you got a real exploding tree problem out there too. There's somebody terrorizing trees. That's what these explosions are in Oregon. That's the ticket. Now we get further to the south, and you're going to see a big stack of earthquakes. So, well, what's going on here? This is a place called Cobb, California, but if you click on another earthquake, you're going to see it's called geysers. So depending on which earthquake you click on, you're going to see it's either geysers or Cobb. Both are the same location. It's a geothermal pumping operation at a volcano. And it's being hit by earthquakes, and it gets hit by swarms. The more pressure that's coming in, the more it starts to move. So here's the volcano, Clear Lake, with its Smithsonian designation. And then here's the geothermal pumping operation, where all these turbines are on hilltops, and every pipeline goes into a drill point. Every drill point goes down a few hundred to a few thousand feet into the upper reaches of the volcano. And guess what happens? When force is applied to the west coast, coming from the Pacific Plate, all of a sudden, these weak points, these drill points, come under pressure. Guess what? Professionals denied this and said it couldn't happen. They said it was just chance and coincidence. They said pressure doesn't transfer. I pushed on my table the other day, and I was shocked to find out it moved. Pressure transferring, it's amazing. It was mind-blowing. Now, what we're also going to see are the rest of these locations over across the California-Nevada border going down the California coast. Well, we'll start at the border, and we'll work our way to the south. This is a place right north of Lake Tahoe, west of Reno. We have Steamboat Springs, which is another geothermal pumping operation. We just literally go right over here to the east, north of Lake Tahoe. Here's Steamboat Springs. And the geothermal ops are massive. So if you thought those turbines at the other one were big, look at these. So we're talking a lot of power and force coming out with that steam, not just a little bit. And the name Steamboat Springs gives it away, and you can read the Smithsonian on it if you like to. We're not looking at an eruption, but the force underneath here is spread all the way over to Sunflower and all the way over to past Steamboat Springs itself. So Steamboat Springs magma chamber has come under pressure, and it goes over to the west and over to the east by many miles. Same reason that this location is under pressure, and up to the north, we'll talk about this in a second, what's causing all this. We get down to the central California-Nevada border. We have two small microquakes striking at Mammoth Mountain, Mammoth Lakes, Whitmore Hot Springs. Now, Tom's Place, I had a viewer write me from here. This is 2 kilometers from Tom's Place. So let me show you the location. Here's the coordinates from the USGS. Let's get another sip of that coffee. Okay, so we've got a viewer that lives right here. I mean, there's not many people that, look how many houses are there. So one of these houses belongs to my viewer. And really, we're right next to Whitmore Hot Springs. And here's Whitmore Hot Springs. Here's Mammoth Mountain. And it's a ski resort / active earthquake and volcanic location. I always think of Dante's Peak with Pierce Brosnan, right? The ski resort town. And well, in this case, we're not looking at an eruption, but you try and warn the people and nobody wants to listen. Now we go across the border, and there's something right across the border from here. Now, you'll see Mono Lake. It's the greater volcano here, but we go right across the border, and we have new earthquakes striking just over to the west of Aurora Bodie crater, which is somewhat abnormal. Normally, we see earthquakes down here at the base of the volcano of Aurora Bodie, but it's transferred. Now it's over here on the western side. And this to me says that there may have been some rise over the past few months at Aurora Bodie. If we're spreading out now, if we started at Aurora Bodie and now we're spreading out from Aurora Bodie, it means there's been a slight rise, which means that volcano, there's something moving there. That's what it means. Now, does it mean it's going to erupt? No, it's just a sign that the volcano's in motion. Now let's jump back over here to the west. Single earthquake up near San Francisco. Not that big of a deal, just a 1.3, right? And a 1.5 up in Napa. Well, we were looking at Napa, so we'll start with the 1.5. 1.5, 1.7, 1.3, 1.2, 1.9, 1.7, 1.0, 0.7, 1.4. So really, we begin up here with a 1.5, and we end with a 1.4, mixed in between the largest earthquake striking in the middle, in between these earthquakes, 1.9. And that's normal. This is a normal occurrence for the middle point to get the largest motion. But I'd like to draw your attention to this 1.4. Why did earthquakes suddenly stop at Avenal, California, 6 kilometers? Why did we suddenly stop there? Well, there's a reason. There's a reason that this earthquake struck there. There's a reason that it stopped there. When you see what's right at the location, I think you're going to start to understand why. We have another oil pumping operation, oil well. Look at this. They got the derrick out there. They got the pipeline stretched out. They're doing new drilling as of 2017 at that pad. Here we go. Here's another one that's already drilled and set there with the jack. And it spreads out. This pumping operation right here is one of the largest in California. Now, you might say, what do you mean largest in California? I don't see much going on here. Well, you have to have a trained eye to know what to look for. For instance, look at this mountain here, this mountain range. And we'll zoom in. Looks like sand dunes on the mountains or something, right? Or it just looks like dirt. Or from this elevation, you don't see anything. Let me zoom in some more. And some more. Now you'll start to see these aren't sand dunes or mountaintops. These are all cleared out pads. And I'll zoom in some more, and you'll see each cleared out pad has what looks like ants on them. We zoom in more, and they're not ants. They're drill points. Thousands of drill points along one of your most active fault zones in the world. You just can't write this stuff. Look how many there are. Look. These are all drill points, hundreds to thousands of feet down. Now, I'm not against oil and gas. I totally understand. We need oil and gas for all sorts of stuff. But it might not be wise to be doing this much drilling along an area that's well known for earthquake activity. It just might not be wise. Why? Well, have you guys ever drilled into something solid? In construction, I have. We've seen it all the time with all types of multi-layer countertops. You drill into that sucker too hard, or you put a perforation on it, it will break if you apply pressure to it. And that's just with a few sheets. That's just a few layers thick. If you go over a vast distance and you have many layers weighing trillions of tons, or God knows how much, billions of tons, the same thing is going to apply, but the weight involved is going to also add into the factor. The heavier something is, believe it or not, the easier it is for something to split and break and find a weak point. Yeah. Well, it's conversely too. When you get into the super thin or super light or super fragile state, lattice work and those kind of things, that also gets fragile. So we're talking about it as something that can break over a vast distance just due to the weight of its own self, collapsing under its own weight. But in this case, it spreads out. So that's what we're dealing with at the pumping operations. Now we go back over along the California-Nevada border. We're going to go pull up this one, Coso Junction. Now you need to add a word into this, Coso Volcanic Junction, because that's where we're going in on. And this is a marked field from the Smithsonian again, so it's not like the USGS doesn't know about it. And the earthquake is striking right next to a place called Devil's Kitchen. And at Devil's Kitchen, they've drilled in, and it's not my name for it, that's what they call it. It's another geothermal pumping operation that's providing electricity for the area, but it is vulnerable now. It has become vulnerable over the last several months. Why? Well, the force is traveling down the plate. It's going into the geothermal pumping operations, which they just drilled a little too hard and a little too deep, and now here we are. You're vulnerable, and you're going to keep getting hit, and you're going to get hit by larger earthquakes over the next several months and years as this force travels across your area. Weak points, whether they're geothermal, whether they're oil or gas, fracking or wastewater disposal, does not matter. They are weak points. Now, here's something that you don't see every day. A diagonal line of quakes spreading from Santa Barbara at the pumping operations near Ventura all the way down to the volcano, Salton Sea at the geothermal pumping operations. 1.4 where we start, and let me show you the pumping operations nearby. And then we're going to make this diagonal line right across the area east of LA, which is matching up with the San Andreas. But first things first, let's show you what's at this location. So here we are. Beautiful California. Oh wait, hold on. Right down here to the south, where one of our larger pumping operations are, in the foothills, you see them again. We've got ourselves our oil and gas pumping operations. Imagery as of 2017 doesn't stop there. From what I understand, that in the last year, they've opened up for exploration along here, up to the north. That's word that's come to me just from people that live there. Now there's already some stuff here. I mean, you can see it. We've already got, like they've got pipeline. This is pipeline. These are oil wells. You can see the shadows on these. So they've already got some, but they're getting ready to make this a much bigger operation here than just a few wells like you're seeing right there. Okay? So it's spreading out. The only question is, how much are they going to do? And I think this is a result of what they're doing now. Again, that was a year ago where this imagery is, they got the pipeline spread out and all that good stuff. So that's where we're starting. 1.4 there. Then we're going in a diagonal line down across East LA and going all the way down to Southern California. So let's go down to Southern California, right at the border. It's called Holtville. It's also next to El Centro. So many Californians may know about this Salton Sea area, just south of Brawley. And here we are. So there's Holtville. Here's El Centro. And there's something here nearby that I think you need to see. A geothermal pumping operation, just like all the others. Pipeline, steam, and they also are doing some solar here. But this goes right up to the volcano itself at Salton Sea. Yes, Salton Sea is a volcano, in case you didn't know. Southern California has an active volcano at Salton Sea, east of San Diego, and it was elevated to active in 2012. Now, they said they elevated it to active based upon the dating of some new rocks. Here's another geothermal operation right next to the volcano itself. But it just so happens that they dated the rocks right after a huge hydrogen sulfide emission happened down here or it wasn't sulfur dioxide, it was hydrogen sulfide was released. And that came from the volcano, the magma chamber down below. Huge mud pits. There's normally small mud pits here, but massive mud pits opened up, bubbling, and they tried to blame the smell of the hydrogen sulfide, which eventually they did the testing and found out it was hydrogen sulfide. They tried to blame the smell, this horrible smell, on dead fish and seaweed. That was their cover story for like 2 weeks until somebody did the test, and then they found out and came out, and then they elevated it to active. They said, well, we dated some new rocks, and we found out that this thing's much younger than we thought. Okay, so we start at the pumping operations, and we end up at the geothermal operations. What's right here in the middle? This is a place called Anza Gap, and it's swarming. So the most movement is happening at Anza Gap, right next to it, also to Big Bear. Well, I need to open this up and show you why it's happening at Anza Gap. Now remember, from Salton Sea down here, we go along the San Andreas, which is our big red line here, and it meets up here where Loma Linda is at Big Bear. Well, that's where our 2.7 is, right where the faults meet. Where what faults meet? Where this one, the San Jacinto, meets up with the San Andreas here, branches off, and meets up back down here. So our swarm is happening right here in the middle, and the San Andreas is in motion on both sides. That's the fact. That's what's going on. I just showed you. So the swarm in the middle is a slow slip. According to professionals, slow slips, like I just showed you in the article here in this update, can lead to large earthquakes. But we already knew that because the University of California, Riverside disclosed that this past October in their article about Anza Gap. University of California, Riverside, right next to this swarm, has released statements and studies showing that the plate is in motion here, not just a little bit of aftershock activity or something. The whole plate, that's why you're getting a diagonal line of quakes spreading across hundreds of miles of Southern California, is in motion. It's slow slipping, and slow slipping leads to large earthquakes, not a release of energy. The plate is building tension and it's slowly moving over a short period of time. Right? So let's get back up here to where they're not reporting any earthquakes all of a sudden in the last 24 hours. There's something going on up here. Let's go turn on our real-time tremor map from the University of Washington. See what's going on up here. Last 24 hours. Look. Still going on. We've got ourselves our slow slip going on at Vancouver Island. Look at 48 hours. Look how many hundreds and hundreds of small tremors are being detected as this pocket is moving. But just this, think of this as like a jerking motion. It's not just steadily, oh, I'm slow slipping like a turtle walking down the street. You're talking about a rabbit taking hops and jumps. So it's sudden slow slipping. They need to have a new term for it, quite frankly. We need to come up with a new term for it. A fast slow slip. A sudden burst slip. Ooh, I like that. An SBS. SBS. Slow slip BS. SSBS. Okay, but no, seriously, it's a sudden burst that's happening. And the sudden burst then leads to a larger earthquake somewhere close by where the sudden burst happens, but it's a single earthquake. that adds up to the cumulative total of what just moved over the past several days at this spot. Usually, the earthquake pops off on a nearby plate boundary, not just a fault, but a plate boundary. So a bigger fracture is where the earthquake tries to seek its way out to. That's not my take on it either. We've just seen that happen over and over and over and over again, and for the last 8 years I've been reporting on this. So what are we looking for? I think it's pretty obvious. We're going to be looking for some kind of a release that's fairly significant somewhere in the Pacific Northwest next to this slow slip burst. And the slow slip burst is happening in Vancouver, but there's also something else starting to pick up. Look at the chart again. Look at Northern California. Last 24 hours, we've got ourselves a new development in Northern California next to Redding, equal or even to Eureka. Now, what's right off the coast? Anybody know what's right off the coast? Let's jump over and show you. Northwest California. So we're getting a slow slip right here. Oh, wait, there's a triangular shape bend here. Oh, that's odd. A triangular shape bend in California, pointing out towards the fracture zone. And the fracture zone is under pressure, big time pressure, and it's going to be releasing that pressure very soon. And when that pressure is released, you're going to get an earthquake. It's then going to cause a chain reaction that spreads down the coast, going down towards San Francisco at Napa Valley. That'll be the next stop. So slow slip leads to earthquake, leads to other earthquakes stretching down the coast, then pushing over to the Midwest, to my neck of the woods, and hitting at the fracking operations in the Midwest at the New Madrid seismic zone. Did you hear me say that? New Madrid seismic zone, as opposed to the old New Madrid seismic zone that's in Missouri. The new Madrid seismic zone is Oklahoma, Kansas, and Texas. And we here in the old New Madrid seismic zone in Missouri, Illinois, Tennessee, we appreciate you guys taking away the pressure for good. You've drilled into the crust tens of thousands of times, and there's no putting Humpty Dumpty back together again. You've interfered with the flow of force coming across the edge of the craton forever now. You could cap off each individual well with concrete and rebar, and fill it with liquid molten metal and let it harden into solid things of metal. It still doesn't matter. You have fractured the crust, and you are now forever going to be the spot where it releases mainly. And we will receive the leftovers coming off that, but it all comes from the West Coast. So our pushes come from the West Coast, and it happens over a short period of time. New earthquake has just struck in the Midwest. 3.2 has just struck in Kansas, fulfilling our forecast for Kansas for this week. We issued the warning for Kansas. Kansas has now been hit. Let's open back up a copy of Google Earth and go put in the coordinates. Show you what's at the location. Kansas-Oklahoma border. Guarantee you guys felt that one. And in the 3 range, you're going to feel it. Probably catch you off guard, make you think it's something a little bit bigger. What's at the location? Well, I think you're going to see it. First of all, we have a wind farm. But secondly, we have an oil pumping operation. Wind farm small, there's only 2 of them there. But you can see our oil and gas pumping operations spread out across the location. You can see the wells, you can see the shadows. They are date as of 2017, so it's fairly recent imagery. And we are right next to that. Probably one right here. Somewhere nearby. Well, 2017, they could be out there doing new drilling right now for all we know. But we're definitely close enough to the oil patch right here to be related. We look within 6 to 10 miles and we're right across one farmer's field. One farmer's block, which is a mile usually. Okay, well, all right. That's where we're kind of going to have to end this. I want you guys to keep watch. I want you to watch the earthquake spread across the plates. I want you to have a plan. And most importantly, you need to live by this. And I know it sounds cheesy, but for real, you need to, don't be scared, be prepared. Being prepared means to watch, kind of like we'd watch the weather. So you're going to watch the earthquake spread across the plates. It's the same reason we're getting 4.8 spreading across the West Pacific right now. You start seeing 4.8 spread out, you shouldn't be shocked if you get hit along the way. And you see which way the arrows point, you know which way that's going to go. So it's pretty basic. It's like, again, like I said, watching the weather. So if you see dark clouds form off on the horizon, you kind of know a storm is coming. In this case, the activity is spreading out and forming out in the West Pacific, and we can watch it come our way in the course of days. I would encourage you guys, I'm going to share this as a video over on YouTube, so get it out, let everybody know, and I'll be on tonight at 10 p.m. to do a full update on what happens throughout the day today. If anything big strikes throughout the day, I'll be back on. Until then, word up and much love. Please subscribe to the channel. I hate even having to ask for it, but subscribe to the channel if you can, and give the stream a like. It doesn't make any difference really, but it does make it look better, so you could like the stream or share the information. See you later. Peace out. Much love.